So let's discuss how to find the volumes of what we call the solids of revolution. So how to get a solids of revolution? We're gonna get a region and we're gonna rotate it about an axis. When you rotate it about an axis, what you get is what we call a solid of revolution, because the area is gonna sweep through a solid. So these are what we call solids of revolution. So it's simply like this. So if you have a region, and once you rotate it about, let's say, about the x-axis, so what's going to happen is going to go around the axis, so it's going to create a solid. So that's the kind of situation, so it's going to create a solid. So we try to find the volume of those kind of things, and what's going to happen when you slice it. So one thing we do is you're going to slice perpendicular to the axis of rotation. So that's very important one. So you're going to um, slice it perpendicular to the axis of rotation every time. Like when you use the disk method, you always do that. You're gonna slice it perpendicular to the axis of rotation. So when you do that, you're gonna get circular disk, because since it's a rotation, so you get a circular disk. So it's different from the previous one. In that case, you can have any kind of cross section, but now you get a circular disk. So what you're gonna do is you're gonna cut perpendicular to the um, cut perpendicular uh, to the axis of rotation, to the axis of rotation, axis of rotation, axis of rotation. So it can be anything. It can be the x-axis, y-axis, or some other line. For example, x equal -1 or y equal 3, something like that. So it can be any line like that. So you're gonna cut perpendicular to the axis of rotation. Okay. So it's very important. Then what you get, the cross section looks like a disk. So let's draw a situation. So let's say we have a curve. So I'm gonna draw the curve like that. Some function. Okay, so this is y equal fx function between two values. So let's go from A to B. So that's where the region is. So it's a region. Okay, the area, the total area. So what we're gonna do now, we're gonna rotate this about the x-axis. Let's say, for example, you rotate about the x-axis. So we're gonna draw the rotation like that. And once you do that, what's gonna happen? It's gonna reflect about the x-axis. So you get a area. You get the reflection of that. So that means you're gonna get something like that. It's gonna go like that. So you get something like that. It's just exactly the mirror image of the other one. Okay, that's the mirror image of what you have on the top. So it's gonna go like that, go like this, go like that. Yeah, it didn't it didn't come good. So this is what you get. So then we have like that. That's the image. So this is a rotation. So that means it's gonna be like this because you rotate it. So that's how the solid look like. So you're gonna see a solid like that. So what we're gonna do, as before, we're gonna slice it perpendicular to the axis of rotation. So then when you do that, you actually get a disc. So you get a disc like that, circular disc. So like this. Good. And the other side that you can see, it's like that, like this. Okay. Now, so that's the typical X. So what we're gonna do, we're gonna look at the height in this case. So the height is simply the y coordinate. That's the height. So this is the y coordinate. So you can see this is simply the y coordinate, and the thickness of this one is dx. So you can see the thickness of such a disk. You can call it dx or delta x or dx. We write delta x when you talk about the Riemann sum. We write dx when you look at the integral. So and this is the so you have that this sitting there. So that's the disk. Okay, so that's the disk. Now what we're gonna do is we're gonna find the volume of one such disk and add all the disks together. So so let's do that. So that means this is one such disk. So it's gonna look like that. This is one such disk. So what we want to do is to find the volume of this disk. So to do that, what we're gonna do, we're gonna first find the area. So that's easy to find because it's a disk which has a radius. So that's the radius. Uh, this radius is simply equals to the y coordinate in this case, but not always. The radius is equal to y coordinate in this case. And also we know the thickness, so we can write the area. So the area of this region is simply we can write ax because it's a dx problem. So we gonna distinguish between, so whether it's a dx problem or dy problem. It's a dx problem. So that means you write everything in terms of x. So it's a disk. So that means pi r squared. But you can see what is r in this case. R is y in this case. So we to exaggerate, sometimes we write this one as pi. Uh, R is a function. We can write it like that. R is a function of x and then it's square. So we can write it like that just to exaggerate. But in this case, what happened? It is simply pi y squared, but not always. So be careful. It's not always y, but pi r always y. So that means we can write the volume formula. So volume is simply pi. You integrate from a to b. Whatever the radius, so let's say radius squared dx. So you can write it like that. So that is the formula for the. Sometimes we use this lowercase, uppercase, it doesn't matter. R is the radius of the disk, typical disk. So that is the formula. And then, so in this case, what we have is this is the rotation about the x-axis. Okay, the rotation about the x-axis. So this is the rotation about the x-axis situation. Uh, yeah, I should have earlier. Okay, let's try it. So this is the rotation about the x-axis. So because you get different values for the radius every time. So that's a formula. So it's pi a to b r squared dx. R is the radius of the disk. Okay, so the r is the radius of the disk. R, which is a function of x, is the radius of the disk. Okay, so let's try to do a couple of examples to understand how it works. So as the first example, let's do this problem. So what the problem says, the region enclosed by y equal x squared and the lines y equals 0. Y equals 0 means x-axis, and x equal to is rotated about the x-axis. This is important. X-axis to generate a solid. Find its volume. So the best thing would be to draw the situation. So let's talk about. So it is in the first quadrant. So we're gonna draw it. So we have y equal x squared. So this part is not really necessary. So we can write a dotted line, and then this y equal x squared go like that. So it says the region enclosed by y equal x squared, and then y equals 0. That's that line. That's x-axis, and then x equal 2. So that's the x equal 2 line. So that's the region they talk about. That's x equal 2. So what they can do, they can rotate this region about the x-axis. So when to rotate, what's gonna happen? This is y equal x squared curve. So what's gonna happen? It's gonna reflect to the other side. So it's gonna go like that. Okay, so it's gonna reflect. So it's gonna go like that. And then what we normally do is we can draw a typical radius. So the typical radius looks like that. So that's the typical radius. The complete disk is like this. So that's the complete disk. So the radius is so we can mark so this is the radius. That's the radius. So in this case you can see that the radius is simply the y coordinate. Okay, so that's the radius. So I'm going to call it r. So the radius is simply the y coordinate. So you can, so its radius is a function of um, function. So that's the radius. It has to be a function of x. So this is simply the y coordinate in this case. But we know that the y coordinate is simply given by x squared. So that's the radius. So we write the radius function, and the limits are very clear. It's going to go from 0 to x, and it's a dx problem. So you can see the thickness. That's the thickness, which is in the x direction, so dx. So it's a dx. So that's the thickness. So we can write the volume formula. So the volume is so pi a to b radius squared dx. So let's plug in here. It is pi a to b. So it is 0 to 2 in this case. So radius is x squared. So we can put it there. So it is x squared. That's the radius squared. Here is squared is again dx. So that's what happened. Because in other words, so actually we can write extra line here. So a to b. In this case, the radius is become y coordinate. So it's a y squared dx. And then the y is equal to x squared. So we plug in here. Now you can simplify this. So pi. So this is 0 to 2 x to the fourth dx. Some of the steps you can skip, but I'm writing everything now. So you can see this is x to the fifth over fifth. So it is 2 to 0, and then when you plug in 2, so it's 32. So it is 32 pi or 5 pi. This is a volume, so it's a unit a cube. So that is the that is how you find the volume of using the disk method. So what you want to do is you want to find the radius, but you can see that the radius is simply the y coordinate in this case. So let's do another example. So the problem is the region enclosed by y equal 2x plus 1 square root x-axis and the line x equal. So there are three things. This curve x-axis and the line x equal 3 is rotated about the x-axis. This is very important. X-axis to generate a solid, find its volume. Again, so let's try to graph this one. How to graph y equal 2x plus 1? So you can see the general shape of that curve has to be a square root function because the rest is just a translation part. So it has to be a square root type of function. We know how to what is the square root type of function, how it what is the shape of that general shape. So general shape is like if you have a square root, it just go like that. So what you want to do is you want to like shift it. So when you have 2x, what's going to happen is just a scaling, and then so it still have the same shape. When you have plus 1, what's it going to do is going to shift it. It's going to shift it to the left by 1. So left by 1. So the 2x curve left by 1. So that, and then also you know that when x equal negative 1 half is going to be 0. So that's a key information. When x equal negative 1 half, it is 0. So that means the graph has to look like this. So let's draw it. So we have so it's a square root function, but it's going to start at negative 1 half because that's where it's going to be 0. So it's going to start at negative 1 half, and it's going to follow the same shape of a square root function. So it's going to go like this with square root function. So that's the shape of the one, and you can see this number is negative 1 half because that's where it's going to be 0. And then what's going to do, so you can see that the region enclosed by the curve x-axis and x equal 3 line. So that's the x equal 3 line. So what we're going to do, this region rotate about the x-axis. So when you rotate about the x-axis, it's going to reflect to the other side. So it's going to look like this now. It's going to go like that. It's going to look like that. Okay. Now, so that's the other part. So that is the solid you are talking about. Good. So what you want to do is you want to find the volume of this one using the disk method. Very simple. As before, we draw the typical radius here. So that's what you get. when you cut it. So again, what you need is the radius. So the radius is r. So you can find that because it's simply the y coordinate. So this curve is y equal 2x plus 1 square root, and you can see the radius is simply the y coordinate. Okay, that's the y coordinate. So so we can write it. So again, it's rx, not ry. It's a y coordinate, but y coordinate equals 2x plus 1 square root. Okay, very good. So we can have the volume formula. So the volume is pi a to b r square dx. So we can plug in here pi a to b. A is, so what's the starting value? So you can see that it's negative 1/2. That's the starting value, and go all the way up to 3. And r is equals to, so again, so this is pi negative 1/2 to b. R is equal to y coordinate, so this is y square dx. So but y equal to that, so it is 2x1 square root whole thing squared dx. So you can see the u squared is square root, so that means it's simply going to be so it is negative 1/2 to 3 2x plus 1. This is very easy to integrate, so you're going to get pi, the integral is 2x means x squared, and then plus 1 means x, so it's x squared plus x. So you have to with 3 and negative 1. So let's plug in the values. So we have pi, so if you plug in 3 you get 9 plus 3 minus, if you plug in negative 1 squared means 1, negative 1 so 0, so that means you simply get 12 pi unit cube. Okay, so that's whatever the unit cube. Good. So that is the volume of the solid generated. So now what we want to do is, so we talk about how to do problems using the rotation of the x-axis. So let's do rotation about the y-axis now. So we can talk about so the rotate about the y-axis. So again, so what we can do is the same formula. Only thing is you x now become y. So same formula. Same formula. Okay. So let's do this problem. The region enclosed by y equal x squared, you can see that's the exact same curve before, so you can see the difference. Y axis now, and the line y equal 4 is rotated about the y axis now. So that's the difference, the y axis. Find the volume of the solid generated. So as before, what we're gonna do, we're gonna draw the situation. So what we have is, so we still have the same parabola. So what we're gonna do now is we're gonna rotate this one and also go up to 4. So the region what we are talking about is the y equal x squared parabola, and then y equal 4 line here, and then the x-axis. So you can rotate about the not the x-axis, y-axis. Now you can rotate about this one about the y-axis. So once you rotate about the y-axis, what's gonna happen? It's gonna reflect to the other side. So it's gonna look like this now. So this is the shape of the solid. So what we're gonna do now, remember is we talk about this before, we cut perpendicular to the axis of rotation. So that means in this case we're gonna cut along this perpendicular to the axis of rotation. So that means this is what it looks like. So as before, what we need is the radius of this one. So but you can see that's the radius we are talking about. That's the radius. So you can see the radius is simply equals to the x coordinate now. So last time it was the y coordinate, now it is the x coordinate. So that means in this case you have extra step, you have to solve for x first. So we're gonna do that. So what we have is And then also you can see this is a dy problem. It's not a dx problem, it's a dy problem, because you can see that this disk moved from the bottom to the top. So that's why it's moving. So it's moving in the y direction. Okay, it's moving in the y direction. Disks. So you can cut it along the perpendicular y-axis. So that means this move in the y direction. That's a dy problem. Okay, that means everything has to be in terms of y before you integrate. Everything has to be in terms of y before you integrate. So let's do that. So that means we have first we have y equal x squared. So the first step is you have to solve for x. So that means x is square root y. So that's the first step. We have to write everything in terms of y in this case before you integrate. And the radius. So the radius uh, is a function of r is a function of y now, okay, because we have to express, but this is simply the x coordinate. You can see the radius is equal to x coordinate, so this x equal to square root y. So that's how you get it. Okay, you can go pass through that. Now we can have the volume. So the volume is as before, it's a pi. So you can say it is going from 0 to 4. Those are the y limits, okay, and the radius square dy. So it is pi 0 to 4. Radius is square root y. You have to square that dy. So you can see it is simply pi 0 to 4 y dy. Very simple integral. So that means it is pi y squared over 2 evaluated at 4 and 0. So when you plug in 4, you get 16 divided by 2. So it's going to be 8. So it is 8 pi unit cube. Okay, so it's a very simple problem, but this is how it works. So so let's look at another problem, but now so let's see like a little slightly different problem. It's a little complicated. So how about this one? So the region enclosed by y equal uh, y equal 2x cube minus 1, the y-axis, and the line y equals 7. So those are three important information. Y equal 2x cube minus 1, y-axis, and the line y equals 7 is rotated about the y-axis. So again, let's graph the situation. So you can see what is the shape of y equal 2x cube minus 1. You can see it is a shape of a cubic function. It's a cubic function. So by multiply by 2, it's just going to scale, doesn't change its shape much. And then you're going to pull it down by -1. And then also you are interested in only the region enclosed by that curve, y-axis, and the line y equals 7. So that means it's going to look like this. So we have so that's the y-axis, that's the x-axis. So that means it's going to be a cubic function, go like that, and it's going to be pass through -1. That's the -1 point. So that's the shape of that part, and then this is the line y equals 7. So y equals 7 line. So that's -1, because you can see when you play x equal 0, you get -1. Okay, now what we're going to do, we're going to rotate this region about the y-axis. So that means it's going to jump to the other side. So it's going to be like this now. Okay, so what you're going to do is as before, we need the radius. So let's mark the radius now. So this is the radius we are looking for, and that's the typical cross section. Again, cut perpendicular axis of rotation. So the radius is this. That's the radius. And you can see again the radius is simply equal to the x coordinate. So that's the x coordinate, they are the same. That's simply equal to the x coordinate. Good, because you pick a general point x, y, so that's why it's x coordinate. Good, so we can write everything we have. Again, it's a dy problem because you can see the thickness is along the y direction. It's a dy problem. That means everything you have to write in terms of y. So we solve for y, solve for x. Okay, everything has to be in terms of y. Okay, so y equal, we have 2x3 minus 1. So what we're gonna replace x by a function of y. So that means you have to solve for x. So if you solve for x, what's gonna happen? This is y plus 1 divided by 2. Take the cube root. So this so x equal y plus 1 divided by 2. Take the cube root. So that is x. So the radius in this case r has to be a function of y because it's a dy problem. You can see this is exactly equal to the x coordinate. X coordinate is simply given by this. Okay, so we have everything we need, and you can see it's a function of y now. So that's exactly what we need. Uh, so let's use the formula. So if you the formula, the volume is again given by, what are the limits? The y limits going from -1 to 7. So it's a -1 to 7. So we have pi r squared dy. So let's plug in. So it is a pi -1 to 7. What is r? R is equal to y over y plus 1 over 2 cube, and then you're going to square. When you square, what will happen? The 1 becomes 2. Okay, that's happen when you square, and dy. So that's the problem. So we can do some kind of simplification here before we do the integral, and you can see that we can take the pi out, and also 2 to the 2/3 power. 2 to the 2/3 power means what? 2 to the 2 means 4. 1/3, that means 4 cube root. So you can write it like that. Okay. And then we have -1 to 7. What we have? Y plus 1 to the 2/3 dy. This is a very simple problem. If you remember the 4 formula trick, especially you don't want to use substitution for this problem, because when you add or subtract a constant, you can simply ignore that when you do the integral. You can simply treat this exactly like y. So remember that trick. When you add or subtract a constant, you can simply treat this as y. So that means this integral is simply going to be pi divided by 4 cube root. So what's going to happen here? So y plus 1, you add 1, so that means 5/3 divided by 5/3. That's exactly what happened. And then you can see if you substitute, you get the exact same thing. So you can use that as a trick. So this we discussed this in a 4 formula trick. Okay, now what we're gonna do is we're gonna plug in the values here. So you can do some simplification. You can write this on 3/5. So it is 3 pi over 5 4 cube root. And then when you plug in 7, this becomes 8. So 8 to the so what time? 8 to the 5/3. This we can simplify. Minus, what happens when you plug in -1? This becomes 0. So it's 0. Okay, and then also you can see 8 5/3. You can simplify. When you do this kind of problems, what you can do, you take the cube root first. 8 cube root means 2, and then raise to the 5th power. That means you get 32. So 32 times 3 means 96. So it is 96 pi over 5 4 cube root. So that's the final answer. Unit cube, because this is a volume problem. So these are like kind of good examples that you have. So I'm gonna do like just few more examples just for more practice, but we cover all the basics now. Okay, so these are like just few extra examples with varying difficulty. So and then theory is over. So what we're gonna do is we can rotate about some different axes. So let's say this one. So what the problem says, the area enclosed by y equal ln x. So this is a different situation. Y equal ln x, x-axis, y-axis, and the line x, y equal 2 is rotated about the y-axis. Find the volume of the solid. So again, as before, so let's try to graph the situation. So what we have, so this is y-axis, and then we have the x-axis, and the curve is ln x. We know how the ln x looks like, so this is the ln x graph. So what we can do, we're gonna rotate the region bounded by x-axis, y-axis, and the line y equal 2. So this is the line y equal 2. So this is the region they are talking about, this region. So they can rotate this region about the y-axis. So when you do that, it's going to reflect to the other side. So it's going to go like that. So that's the one. So then this solid looks like this, and so that's a solid. Okay, so as before, what we're going to do is we're going to find the radius. So that's the radius. I'm going to call r, and we know that that's exactly equal to the x coordinate. That's exactly equal to the x coordinate. So problem is pretty much similar. So again, we need to solve for, because you need to write everything in terms of y. So let's do that. So we can start with y equal ln x. You solve for x. So x equal e to the y, that we know. And then the radius. So radius, which is a function of y, is equal to the x coordinate, but we know the x coordinate equal to e to the y. So that is the different step here. So we have like a switching functions now. Okay, and then the volume. So the volume is as before. So what are the limits of the y coordinate? So you can see it's going from 0 to 2. Y changes from 0 to 2. So this curve is actually y equal ln x. That's the curve. Okay. So we write this one as x equal ey. So it's the same curve, but we write as x equal ey. Good. And then so we have pi radius square dy problem now, because we cut it perpendicular to the axis of rotation. So it's slicing, the thickness of a slice is dy. Good. So it is pi, you can take it out, and 0 to 2. So radius is equals to ey. So it's ey, that is square dy, and we can use some college algebra here. So you can see when you square this one, it's become e to the 2y dy. And then we also know how to integrate e to the kx. So what happens if you have e to the kx? We simply divide by that constant. So that's how we integrate. We discussed that in substitution problems. So we can use that idea here. So that means a pi e to the 2y divided by 2. Whatever the constant, you divide by that. If it's non-zero. And then the limits go from 2 to 0. So when you plug in that, so it's a pi over 2. So when you plug in 2, so it becomes e to the 4y, minus when you plug in 0, it is 1. So that means it is pi over 2 e to the 4 minus 1. Again, unit cube. Okay, so that is the volume of the solid generated. So the extra interesting step is you rewrite this. Okay, you solve for x first, because you can see that way you can express everything in terms of y. So you have to do that before you integrate, otherwise your answers are wrong. Good. I hope it's very clear now. So what I'm going to do, let's talk about rotating about some other axis. Uh, so let's see, rotated about other axis. So rotated about other axis. So let's do this problem. So what the problem says, the region bounded by y equal square root x, y-axis, and the line y equal 2 is rotated about the line y equal 2. So now it's a different line. It's a y equal 2. Find the volume of the solid. So again, so let's graph the situation, because it's always useful when you graph these kind of complicated problems. So I'm going to graph it. So this is the y-axis, the x-axis. So we have y equal square root x curve going like that. So what they're going to do is, what's the region they are talking about? So it's y equal square root x here. That's the curve. And then okay, and then and then y-axis and the line y equal 2. So that's a y equal 2 line. So I'm going to draw that line here. Uh, okay, so this is the line y equal 2. Y equal 2. So what they're going to do, they're going to rotate upon this axis. So this is a different line. It's not x-axis, not y-axis, so y equal 2. So what's going to happen when you do that? It's going to reflect to the other side. So it's going to go like this now. So you can draw it. It's just a reflection of that around that line. So this is what you get. So what you want to do is, so this problem will be slightly different from the previous problems, because now what's going to happen when you mark the radius, so that's the radius you're looking for. So there are, I mean, you can get the radius from the top or the bottom, it doesn't matter. But what do you want to do, what do you want to think, which is easier to find? You can see we already know the curve of the bottom curve. We don't know the equation of the top curve. So that means when you want to find the radius, use the bottom one. So I'm going to use the bottom one to find the radius. So that's the radius you're talking about. So how to find it? So you can see that this total length is 2. So you can see this is the total length, which is 2. And we also know that this part, I'm drawing like that. This is simply the y coordinate. So that means you can use this geometry, find the radius now. So you can see that the radius is simply 2 minus y. So that is how we're going to find it. So we are not going to use the top here. We only use the bottom part because that's the easier one to find. So actual radius is going like diameter going like that. But we try to find the radius from the bottom part because that's easier to find. Okay, now the top. The top we don't know the curve. Okay, so we can use that fact and then we can write this information. So the radius in this problem is r, which is simply equals to 2 minus the y coordinate. But we know that what is the y coordinate? Y coordinate is simply square root x. So that is the formula, and you can see that this is a dx problem. So that's exactly what we have. So that's the dx. So that means everything has to be in terms of x. So we have it in terms of x. So now we get the formula. So we so this is a to b pi radius square dx now, because we're going to cut perpendicular axis of rotation. Okay, so it's everything very clear now. So it is pi, the limits going from 0 to 4. So you can see it is 2 minus square root x, that's the radius, squared dx. So if you need to set up the integral, that's it, you're done. That's the setting up the integral. Rest is just the from evaluating the integral. So how to evaluate? So what we're gonna do first is we're gonna distribute inside. So if you distribute, you can see you square the first term twice the product. So that means it's gonna be 4 square root x, and then plus if you square the last one you get x. That's what you get, dx. So these are easy to integrate. So we can do term by term integration. So it's 4x and minus 4. So this is x 3 halves divided by 3 halves plus x squared over 2 evaluated at 4 and 0. When you evaluate at 0 is gone. So what you want to do is only evaluate it at 4. So if you plug in 4, you get 16 here, minus you can see that you can write this one as 8/3 first, and then so this is 4 to the 3 halves. That's very simple. We go to the square root first. That means 2 to the cube. That means 8. So you get 8 here. Plus if you plug in 4, you get 8, and then minus 0. So this is very easy to simplify because we know that this part is simply 8. We take the cube root and no, take the square root and take the cube. Okay, that's why you get 8. So that means you finally get 8 third pi unit cube. So that's the final answer. Okay, so let's look at a similar region, but now let's rotate about a different axis. So I'm gonna rotate the similar like slide. I mean, it's the same curve, but slightly different region. So let's actually I want to highlight the region. So this is the region we were talking about in this case. Okay, good. So let's do this one. This is very similar problem. So I'm gonna call this is part B. So it says the region bounded by y equals square root x, x-axis, and the line x equal 4 is rotated about the line x equal 4. So let's graph the situation again. So we have y-axis and then the x-axis. So it is a y equals square root x curve, let's go like that. And then the region is, so this is the line x equal 4 line. So what we're gonna do, we're gonna rotate this region about the x equal 4 axis. So that's the axis. This is y. This is x. So what's gonna happen is gonna jump to the other side. Um, so this is the solid we are talking about. Good. So again, as before, now what we're gonna do is we're gonna find the radius. Again, you can find the radius in two different ways. You can have a radius on this side, or you can have the radius on the other side. So what we can do, we're gonna find the easy one because we already know the curve of this side. So this is so this curve is y equal no, not that side. That side we don't know. Think about how to get the curve of that side. So this curve we know. So this is the y equal square root x. So we know that part, that side. And then when you plug in x equal to the square, so it's gonna go up to 2. So we can simply find the radius. So this is the radius. So we can get a formula because we know the total length is 4. So what you need to do is you need to simply subtract the x coordinate because this is the x coordinate. So if you mark it, this is the x coordinate. So that's the x coordinate. So what we can do is we can use that fact because we know the total length is 4. So from here to there is 4. So find the r, we can subtract the x coordinate from this one. So that means we need the x coordinate. So we're going to solve for that. So that's where the starting point. So we have y equal square root x. This is that x equal y squared. So we have that. And the radius. So the radius, which is r. So you can see it's a dy problem. So it's ry, radius. This is simply, you can see it's a 4 minus the x coordinate. It's simply coming from the geometry because we know that the r plus x equal 4. So that means r equal 4 minus x. But x we know that it is simply 4 minus x equal to y squared. So we're gonna put it there. Okay, because we know that this is simply the y coordinate. Okay, so we have everything we need. So we can integrate now. So the volume equal again a to b pi radius square is a dy problem. Dy problem. So let's plug it. So it is pi. The limits. Okay, what is the limit of the y? So you can see the limit going from 0 to 2. So it is 0 to 2 because of the y limits. And then the radius is simply equals to 4 minus y squared. That's the radius, but you have to square that dy. So this is the integral. Okay, that's the integral. Now what we want to do, we want to simplify that part. So how to simplify? You have to distribute that first and then integrate term by term. So if you distribute, so you're gonna get, so 0 to 2. So if you distribute, you're gonna get 16 minus your twice the product. So you get 8 y squared plus y to the 4th power dy. So this is a term by term integration. So pi, so it is 16y minus 8 third y cube plus y fifth or fifth, and then 2 and 0. If you plug in 0 is gone. So if you plug in 2 and simplify, so what do you get? So if you plug in 2, you get 32. And if you plug in 2, this is 8, so it is 64 third, and then this is 32 fifth. So if you simplify, and minus 0, so if you simplify, you get 17 1/5, 115 unit cube. Okay, so that's how we do a problem with a different axis. So now what we're gonna do is as the final part, we're gonna set up integrals. I'm not gonna simplify the whole integral, but we just set up the integral for the volume. So let's do that now. Uh, so set up. So let's say a problem like this. So we can do now the setup the integral. So you don't evaluate, you just set up the integral, because those integrals can be really complicated. Set up the integrals for the volumes of the solid, generated by rotating the region, uh, bounded by the curves about the given axis. So the axis is also given. So as the first problem, let's do this one. So the first one is I'm going to call A, y equal e to the x, y axis, and y equal 3. So those are the curves about, so let's say rotate about y axis, okay. So those are three curves, and then we're gonna rotate about the y axis. So let's graph this. So we have what we have here. So we have uh, ex, y axis, and y equal 3. So that means it's gonna look like this. This is ex, and then we have y equal 3. So that's the y equal 3 line, and the y axis. That's the y axis. Okay, so we can rotate about the y axis. If you rotate about the y axis, what's gonna happen is gonna jump to the other side. So it's gonna look like this. Good. And then the radius. So you can mark the radius. That's the radius. That's r. We already know the curve. So this is y equal ex. That's the curve. So it's gonna start with 1 all the way up to 3. So we're gonna find the radius. So radius is again equals to the x coordinate. This x coordinate. So that means we have to solve for that. So it's a y equal ex. So we have to solve for x. So x equal, this is ex. So that means ln y. So that's what you get. So we can write the radius now. So the radius is r, which is equal to the x coordinate. X coordinate equals to ln y. So we have to do that because it's a dy problem. That's why we have to do it. So we can write the volume formula now. V equal 1 to 3 pi r square dy. So it is pi 1 to 3. R is ln y squared dx. Dy actually. It's a dy problem. So how to do this? You can see that you want to do this using the integration by parts. Okay, so if you want to solve it, you have to solve it using integration by parts. It's a difficult situation right now. Okay, we know that you have to pick u equal ln y squared if you want to do it. Okay, so let's do the next one. B. So B, we can look at these three curves. So let's say we have y equals sine x, and then y axis, and then y equal 1 line about about the y-axis, about the y-axis. So let's do that. So if you look at the graphs, so this is how it looks like. So this is a sine graph, so it's going to go like that. And the y equal 1 line. This is y equal 1 line. And then the y-axis. So this is the region they are talking about. So you can rotate this region about the y-axis. Okay. Good. So if you do that, then it's going to jump to the other side. So it's going to look like that. Good. Doesn't look good. So so radius. So what's the radius here? So again, we cut it perpendicular to the x-axis, cut y-axis in this case. That's the radius. Again, the radius is simply equals to the x coordinate. So you're gonna mark it. So that's the x coordinate. So this curve is y equal sine x. So that means we have y equal sine x. So we have to solve for x. So that means x equal sine inverse y. So the radius r, which is a function of y, so that's simply x coordinate, which is equal to sine inverse y. So we got the volume formula now. So v equal, the limits are going from 0 to 1. So 0 to 1 pi, the radius is y sine inverse y whole thing square dy. So you can write this as pi out 0 to 1 sine inverse y squared dy, and you can see that this also you have to use integration by parts for this problem. Okay, so let's do part C. So what's the part C is about? Let's say y equal sine x, and the y-axis, and the y equal 1 line. Let's say about y equal 1 line, y-axis. Okay, so that's actually rotation. That's actually rotation. So the same region, but we have different axis now. So let's graph it again as before. So this is sine 1, so we have pi over 2 here. That is the line y equal 1. So this is pi over 2. So now what we can do, we can rotate this about the y equal 1 line. So that means the graph gonna reflect to the other side. So it's gonna go like that. Good. So that's how what it looks like. So the radius, again the same argument. So you can see you can find the radius easily using this side. Okay, that's the radius, and we don't know the top curve even. Okay, so this curve is, we know this is the sine curve. So y equal sine x, but what we need is okay. So what we need now? So we need to find r, and we know this gap. So this is simply 1, and this is the y coordinate. So if this is the y coordinate, so you can write the radius now. So what's the radius is? So it is r equal 1 minus y, and this is a dx problem because it's gonna go in the as a thickness. This is in the x direction, so dx is like this. That's an x problem. That means we have to plug in that. So it's a 1 minus y is sine x. So you write it like that. So that's the radius. Okay, that's the radius. So that means the volume is simply pi, limits going from 0 to pi over 2, 1 minus sine x whole thing squared dx. So that is the integral for this one. And then you can do this one. Actually, yeah, you have to use the trigonometric integrals to do this one. So this is a trig integral problem. Trig integrals. Good. So that is that's about the disk method.